Well, hello, pre-calculus students and seekers of truth. Let us end our study here of piecewise functions with an example here that is a little bit trickier. We have an x squared function and a linear graph, 2x plus 1. We're going to use the x squared when x is less than or equal to 1, and we're going to use the linear function 2x plus 1 when x is greater than 1. So what you should get into the habit of doing here is you can plug in some numbers, but I also want to emphasize that we need to check the endpoints. And what I mean by endpoints is the place where the function switches over. So at 1, right, the x squared function will give us 1. Right? At 1, the other function, 2x plus 1, will give us, this will be 2 times 1 plus 1, which is equal to 2 times 1 plus 1, which is 3. Okay, so our graph is going to look, let's give ourselves here a simple scale, just a scale of 1 to 1 here, 1 on the x-axis, 1 on the y-axis. So when x is equal to 1, you have a couple of scenarios. You have this point here, and then you also have this point when this is when x squared is equal to 1. So you have the other point which is equal to 3. So at 1 you have 1, 2, 3. So you have this point here. Now keep in mind we're going to need to draw an open circle on here because we're going to use the 2x plus 1 function for every point that's to the right of 1. That sounds a little bit confusing because it's pretty wordy, but after we do the example, I think it'll make a lot more sense. So, but I wanted to emphasize this here that we want to check the endpoints. We want to start out with where is this function going to switch over. So now let's actually try to graph it, x and g of x. Right? So we already know what happens at 1. What happens if x is less than 1? Let's say x is equal to 0. Well, if x is equal to 0, then we're going to use the top line here. So this is 0 squared, which is equal to 0. So we could put this dot right here. And then if x is equal, let's say a negative number, negative 1. Negative 1 squared. Now keep in mind we need to put parentheses around the negative 1 because we're doing substitution here. So this is going to be 1 as well. So it's going to look like that. And maybe one more negative number, negative 2. So negative 2 quantity squared is going to equal 4. So negative 2, 1, 2, 3, 4. So from what we have here, the left side of 1 is going to be a parabola. So it's going to look somewhat like that. That should be a lot smoother. In fact, let me attempt that again so I can get a better result here than what I just drew. So it's gonna be a parabola. Try this one more time. It's gonna be a parabola that comes down kind of like that. Okay. All right. Gee, I'm still not happy with this. So one more try here. Going to be a parabola. There we go. So it looks something like that. Okay. Now I'm going to switch colors and let's just do the other side of this. What do we have a number that's bigger than 1, like 2? Well, if it's the number that's bigger than 1, then we're going to use this other function. So this is 2 times 2 plus 1, so that's going to equal 5. So 2, 1, 2, 3, 4, 5. And then we have, let's say one more, 2 times 3 plus 1. So that's 6. So that's going to equal 7. So 3 and 7. Okay. So to the right of the function, to the right of 1, we have something a little bit different. It's going to go like this. It's going to have this line here, but it's going to go upwards like that. Okay. So now let's go back to what I talked about earlier when I said, the endpoints. Well, you see here that this endpoint matter for both of them. For the first part, because we need to know where we're going to start drawing from. But for the second one, we're not going to ignore this dot altogether because it helps us understand where this line stops. This is a ray, to use geometry terms, or a half line. And it's going to start from this particular endpoint and go this way forever. We need to know where this dot is, otherwise our arrow may be misplaced. So the endpoints help us to know where this jump is going to occur. In this case, it's going to happen when x is equal to 1, and it's going to jump from y equals 1 to y equals 3. So this is the big idea behind piecewise function, that you really need two different parts, and you're really graphing two completely different functions, but you're using one part of each function just to make the final graph. So this is the graph of g of x. We will look at some more examples in the exercises to see how piecewise functions is used in the real world. In fact, most functions in the real world are piecewise functions. So this is a good opportunity to learn about them. As always, keep persevering. If you struggle with a problem, that's pretty normal. Ask for help if you need it. Thank you for watching, and have a wonderful day.